All right, let me show you how the state pattern can easily be abused. Let's say we want to implement a stopwatch app. In this app, we need a stopwatch class with a click method. When we click it, it either starts counting or stops. So in our state package, let's add a sub package. I'm going to call this abuse. Now in this package, we're going to add a new class called stopwatch. Here we need the click method. Now, depending on the state of this object, we should do different things. We can represent the state with an enum with two states, or we can use a Boolean. I think a Boolean is easier, so let's go with a Boolean. So private Boolean is running. Now, when we click the stopwatch, if it's running, then we're going to stop it. So we set is running to false, and then we print stopped. Otherwise, we're going to set is running to true, and then print running. Let's test our implementation up to this point. So in the main class, we create a stopwatch, and then click it. Initially, it stopped. So when we run this application, we should see the running message. There you go. Beautiful. Now, if we click it one more time, we see two messages, running and then stop. If we click it one more time, we see running, stopped, running. Beautiful. So this is a very simple, straightforward implementation. Now, John Smith takes over this code. He's sitting in the office and he thinks, the click method is behaving differently depending on the state of the stopwatch. So that is the case for the state pattern. He's going to refactor this code like this. First, he's going to create a new class or an interface called state. So we need an interface here. This interface is going to have one method, click, and we're going to have two classes that implement this interface. So John adds two classes. One of them is stopped state. The other is running state. Running state. Now, both these classes should implement the state interface. If the stopwatch is running, we should stop it and then print a message. But how are we going to be able to stop the stopwatch? We don't have access to the stopwatch object here. Well, we can add a constructor. So public running state. We give this constructor a parameter of type stopwatch and then store it in a field. So we declare a private field here, private stopwatch. We call it stopwatch. And we initialize it in the constructor. This.stopwatch equals stopwatch. Now, in the click method, we should change the state of the stopwatch. So first we need to go to the stopwatch class and add a field to store the current state of this object. So we don't need this field anymore. Let's declare a private field of type state called current state. Now let's generate a getter and a setter for this field. That is super easy. There you go. So back to the running state. When we call the click method, we should change the state of the stopwatch. So we call stopwatch.setState. And here we pass the next state, that is the stopped state. So new stopped state. Now here we have a compilation error because this class doesn't implement the state interface. So let's add it real quick. Implements state. All right. Now back in the running state class, the problem is gone. Beautiful. So we change the state and then print a message saying stopped. Now we need a similar approach in the stopped state class. So here we generate a constructor. I'm going to show you a shortcut. If you're on Mac, press Command and N. If you're on Windows, press Control and N. With this, we can bring up the generate palette and generate a constructor. Now here we can add a parameter that is stopwatch. And at the same time, we can create and initialize a private field. So we put the caret on the parameter name, press Alt and Enter, and select create field for parameter stopwatch. There you go. So we got a private field, and this field is initialized over here. Beautiful. Now, in the click method, we should change the state of the stopwatch. So we call stopwatch. That's the current state. If it's stopped, we should set it to the running state. So new running state. Now here we should pass a reference to the stopwatch. That is the stopwatch field that we have in this class. Okay. Then we print a message saying running. Okay. Now we have a compilation error in the running state class, because when we try to change the state of the stopwatch, we're passing a new instance of the stopped state class. The constructor of the stopped state class expects a stopwatch object. So we pass that object over here. Problem is solved. So we have two state classes, and the final part. We go to the stopwatch and replace this implementation with current state dot click. So we're delegating the task of clicking the stopwatch to the state object. And by the way, initially we should set this to the stopped state. So new stopped state. Now here we should pass a reference to a stopwatch object. That is going to be this that represents the current object. We're done. Now back in the main method. So internally we changed the implementation of the stopwatch, but it behaves the same way. Let's run the program. We see the exact same result as before. Beautiful. However, this implementation is way more complex than the simple if and else statement that we had before. So there is absolutely nothing wrong with if and else or switch and case statements. If you have a few decision-making branches in a single method, like how we did in the stopwatch class, we had those decision-making statements in a single place. There is absolutely nothing wrong with that implementation. But in our previous example, in our Canvas class, we had those decision-making statements in multiple places, in the mouse down and mouse up methods. And more importantly, if we wanted to support a new tool, we had to modify different parts of our code. That is the reason why we refactored this code, we changed the structure, and used the state pattern. In contrast, in the stopwatch, all the decision-making was in a single place, and we know that this stopwatch is not going to have a new state in the future. It's either stopped or running, as simple as that. So we don't have a maintainability issue here. We don't have extensibility issue. We ended up refactoring this code. Well, I didn't. John Smith did that. But he made this code overly complicated without gaining any benefits. Now we have more moving parts. We have an interface plus two implementations, and our logic is spread over these two different classes. In contrast, in the previous implementation, all that logic was in a single place. So here's the bottom line. Don't abuse the design patterns.